So welcome to my channel. If you clicked on this video, it means that you're interested in learning about adjustable power supplies, which is neat. I hope I can kind of shed some light on adjustable power supplies, maybe introduce a new way to think about them. You take away something from this video. So firstly, what is an adjustable power supply? Well, an adjustable power supply is a device that can output a lot of power, typically in the form of DC. I've tried researching other kinds of power supplies. To me, it seems like most of them are DC, meaning it's a direct current. So this isn't something like an AC voltage or a triangular or a pulse. It's typically DC and it can supply a lot of power to your device. And DC meaning that the current is moving only in one direction. And typically this output voltage that we can adjust is within a short range. So you'll see later in the video that I have a device that can output, I think, between 0.5 volts and 30 volts. So that would be the output range that we can adjust the voltage to for a variety of devices. Before we break down how a power supply works, I want to first talk about why somebody might want an adjustable power supply. So a lot of electronics, especially ones that involve batteries, need a power supply to charge them. That's why, like the one in your phone, you have your brick, which is like a power supply in a way, but it sets the voltage at 5 volts, which is what USB is. You have power supplies that power your laptops, the bricks that you use to plug into the wall, as in your monitors. Power supplies are everywhere, but sometimes having one that's adjustable allows you to plug into all of those things without needing to have a unique adapter for each one. But the idea is that DC is what allows us to charge, say, a battery in this circumstance. If we were to attach an AC voltage to the output of a battery, things could be pretty bad, because on the chances that the voltage is higher from the source side, okay, we may charge the battery, but the moment it alternates and goes in the other direction, now we have a huge voltage that's pushing current in the wrong direction, going towards the source. And you don't want to do that if you're trying to charge your battery. So with a power supply, with an adjustable power supply, we can fit the need for all of these kinds of devices that we want to mess with. So let's break down how a power supply works exactly. Now, I like to break things down into function blocks. What a function block is essentially, imagine just literally one block with an arrow going in for your input and an arrow going out for your output. And we can always break this down into further groups and get even more technical and more technical. But we're gonna stay kind of high level probably for this video, and then maybe I'll go into more depth in another one. But in this case, the input of our main function block is 120 volts AC in the US, and then the output would be any DC value that we set by the adjustable power supply. Everything in the function is all of the electronics that are involved in making a power supply. And for my DIY adjustable power supply, I'm gonna break this down into two further blocks. So one is just going to be the power supply that I took out of an old computer, and then a buck boost converter. I know it sounds kind of weird. The main power supply does exactly kind of what you would imagine. It turns the 120 volts AC into a fixed 12 volts DC. So that's great. 12 volts fits a lot of different applications, but it has no adjustable feature to it. It's just the main power supply. And then the buck boost converter is what steps up or down that 12 volts that goes into it from the power supply. You can kind of see, I'm gonna show probably a picture of what that looks like. Here's one block of the power supply and another block of the buck boost converter that allows you to step up or down that voltage. So a lot of circuits that are involved in each of these, but these are kind of the two main ideas that play into an adjustable power supply. So let's investigate this further. Let's take a look at the power supply. This here is the first part of our block diagram. This is a old 12 volt, actually it does different voltages, but 12 volt power supply is how I'm going to be using it. It is able to output about 14 amps on its 12 volt line. So it has a bunch of different voltages that it keeps constant. Like I think there's 5, there's 12. There might even be a negative voltage that it can output, but I've cut all the wires off of it except the negative and the 12 volt output. It says on the side that it can do 14 amps out of that 12 volt line. We're gonna test that and see if it can actually do that. What we're looking for is, as we do our current test, we draw up to 14, it should maintain a constant 12 volts. That's how this should be designed. If it can maintain 12 volts all the way up to 14, then that's perfect. We want the voltage not to change from the supply. If we exceed that, maybe it has some protection circuitry in place where once you cross that limit, it shuts off, and then it won't actually output current anymore until you turn it off and back on again. There will be some under voltage protection. If it can't hold it constant up to 14 amps, maybe if the voltage drops to 10 volts or so, it will shut off. We don't know really what's in here exactly. There's probably a lot going on. You saw the circuits before of generally what they're made of. So we're gonna test to see what it looks like when we draw up to 14 amps and then exceed that to see what happens. I have this hooked up to my electronic load. Let's go ahead and turn it on. You can see that it's already reading a little bit less than 12. It's around 11.69 volts. And so as we turn up this voltage, we would expect that to drop a little bit, but stay around that value. You're already expecting it to be at 12, but we'll see. So we're gonna go ahead and start at 1 amp and start discharging it. So it looks like it's dropped a little bit, able to hold 1 amp, and we're getting about 11 watts out of it. Things are still relatively constant, so we're just gonna keep ramping this up slowly. Being a power supply, it should be able to just keep holding that 12 volt value. So or maybe in this case, 11.67. So we're at half of its output. It's only dropped about 0.3 volts so far. So for drawing 7 amps, that's pretty good. I would say that's pretty good. Still above 11.4. We're getting about 80 watts out of this now. So let's keep going. So this should be able to go up to 14, and it should not drop below 11. Wow. So there it goes. So we're at 157 watts. I guess it's a little less because the voltage has dropped quite a bit. So at its rated current value, the voltage is reading 11.2, which is, I guess, 0.75 volts lower than what it says it should be. The input range for our buck boost converter can be anywhere between, I think, around 0.5 and 30 volts. For this power supply, it should be able to maintain 12. Now let's try to go beyond that. I'm going to put it to this setting here and go up incrementally from there. 15.3 amps, and we're still going. Voltage is at 11.2 volts. Wow, 17 amps. 11.1 volts, 11.18. So, still doing all right. Power supply's not too warm either. I don't know if this thing can actually handle much more than this. We're almost at 200 watts of power. Temperature's at 77 degrees. I might actually have to shut it down. But 7.5. Yep, and the voltage right back up to 11.73. So I am kind of curious how high we can go until this thing can't do it anymore. We can do that. I've let it cool down to 30, around 30 degrees Celsius. We got to 17.5 before, so let's start at 15 and do that. So all right, next one here. Still able to do it, 200 watts. Oh, okay, well, this device I forgot I set to 105 watts. Okay, one more time. I raised the limit about 10 watts. I'm hoping that does it. Oh, actually, our voltage just dropped. I just noticed this. So I guess going over to, was it 18 that we reached max, or 19? 19, that seemed to trigger some kind of protection. So now we're reading around 0.32 volts. It was able to go all the way to around 19 amps and stay above 11.2 volts. So pretty good. I'd say that's pretty good. And at least for our application, because there's such a wide input range, should be not an issue for our buck boost converter. So looking back at the next stage, which is the 12 volt buck boost converter, it looks like its input range is anywhere between 5 and 30 volts. So as you saw, the power supply was able to stay between 11 and 12. So relatively stable comparatively. This will work just fine for the next stage of our buck boost converter. And so it's also important to think if you're going to do this on your own, you're kind of limited by your weakest power rated device. What I mean by that is if the buck boost converter is rated to work for 60 watts, but your power supply can handle up to, in our case it said 12 volts, 14 amps, so 168 watts, you're limited by the weakest link. You should not put more than 60 watts through your entire system. So you want to look at what kinds of loads you'll be working with. If you're working with a phone charger, that should be pretty straightforward because charging a phone is only 5 watts. But if you're trying to power a computer, it could be problematic. If you're trying to charge or power a light or a monitor, whatever the case may be, you just want to look at how much power you're trying to supply and pick your parts accordingly for that. Make sure every one of your components is above the rated value of where you're working with. I recommend twice as much, just for safe margins, but that's what it should be able to work with. And in our case, it looks like it says it has an output current of 3 amps for long-term use, but if with better heat dissipation, you could work with 4 amps. But it also says you can reach max power output of 35 watts. So 35, in our case, is much less than what the power supply can handle. Maybe we can push that a little bit more. I'm gonna try to experiment with that. But if the output can be 30 volts at 3 amps, then potentially it could do 90 watts, but we'll have to see about that, see what it can do. But the idea is you never exceed the lowest. So I should not exceed 35 watts. So it's the combination of the voltage times the current. This buck boost converter that I also got on Amazon should have the same over voltage, under voltage, and over current protections. So the circuit that I showed earlier on is a very simplified buck boost converter. Also didn't show a lot of other circuits that are involved there with the control aspect of it. But it looks like this one has those features. So if we do exceed over probably 4 amps in our case, it should trigger that protection. Maybe shut off the device and we'll have to power it back on again. And all these things protect the life of the power supply so that you can continue to use it even when we make mistakes and go above or below what it should be handling. And when you combine these two ideas together, you get an adjustable power supply. I'm gonna now show some videos of the enclosure I worked with, kind of what it looks like all put together. I like messing with electrical things, not so much mechanical. So I designed my enclosure. I should have just bought a box. I just figured designing one and printing it would be something cool to try. So I'm gonna kind of showcase some of the videos of me putting it together and testing it for the first time. All right, here we go. 3, 2, 1. Hey! So it looks like it's currently set to 5 volts. So let's see. Put it up like this here. Let's see how accurate it is. Okay. Yeah, look at that.
Accurate, yeah. Adjust, let's see what we get.
Yeah, let's see what we can do. There we go.
Okay.
Nice. I mean, the real test will be like, all right, we're drawing a bunch of power. All right, is it still maintaining the same the right voltage? Like, that'd be a real test. We could do a current test, a constant current test. So pressing this button to push down on the bigger dial. Let's do 2 amps. So I think 2 amps will be safe. So now what should happen is if we short that, it should be limited. This dial should change to constant current. The voltage will drop and it'll maintain 2 amps. There it is.
Yep.
Voltage dropped to 0.23. It's on 2 amps and the meter says 2 amps. So that's awesome. Yeah, this thing's pretty dang good.
It's pretty accurate. Yeah.
Nice, success.
Yeah.
Cool. Talking a little bit about how power supplies work. Yeah, you wanna be in the video? You wanna say just wave? Here. I'm just videoing video of just taking it apart, so I'm gonna put that. So just wave like this.
Hi.